Kia ora. Another type of calculation is to work out whether a precipitate will form when you mix solutions together. So we use this by calculating the ionic product, which is exactly the same as the solubility product. The only difference is the solubility product applies to an equilibrium system, whereas an ionic product has the same equation, but it is not yet at equilibrium. So if I mix two solutions together and I calculate the ionic product, if the ionic product is less than the solubility product, it means I have too few ions in solution, so any solid will start dissolving to try and get the same concentration of ions in solution so that it reaches equilibrium. Or the other way around, if my ionic product is bigger than my Ks, then I have too many ions in solution, so it's greater than equilibrium. So in order to reach equilibrium, some of those ions have to precipitate out so that my ionic concentration of ions is the same as what it should be at equilibrium. So let's look at a calculation. Will a precipitate of calcium carbonate form if I mix some solid sodium carbonate, which is a soluble salt? All sodium salts are soluble. If I put the sodium carbonate into a solution already containing calcium ions, and then assume no volume change, that statement is made because, of course, our solubility expression always has is to do with concentration. So the first thing you need to do is you go, okay, equation, expression, what is my equation? And if you don't know, look for the Ks. Here the Ks applies to the calcium carbonate, so that will be your equation and it'll be your expression. So there's my equation. Calcium carbonate breaks up to form calcium ions and carbonate ions, and my expression is because it's a 1-to-1 ratio of calcium ion concentration and carbonate ion concentration. The next step is to work out what of the given information belongs to which ion, because they are from two separate sources. So I've highlighted now the ones that apply to both in blue, the ones that apply to calcium in orange, and the ones that apply to carbonate in green. So if I list this, calcium ions are already given as a concentration, so that is great. However, my carbonate, I don't have a concentration. I've got a mass, I've got a molar mass, so you should hopefully be thinking of N is equal to C over V. N is equal to small m over big M, but I am also given a volume and the Ks, which would apply to both of these. So I've got a volume of 250 where my sodium carbonate goes in and my calcium. So let's start with calculating the concentration of the carbonate. So the first step is to work out the amount in moles. If you don't know what to do, calculate moles. So there is my mole of carbonate ions, and now I will find the concentration by taking that amount in moles and dividing it by the volume of 250 milliliters. You'll notice I've multiplied by 10 to the minus 3 because I need units of liters. My units must be in moles per liter, which is why I've added this. And there you'll see an answer of 3.77 times 10 to the minus 3 moles per liter. So that's great. I now have a concentration for calcium ions and a concentration for carbonate ions. Note that they are not the same because my ions come from two different sources. So don't expect them to be the same. Don't think, oh, it's 1-to-1 ratio. The 1-to-1 ratio only works if everything comes from the calcium carbonate. Here, my calcium ions come from my calcium solution I had, whatever it was. Could be calcium chloride or whatever. And the carbonate comes from the sodium carbonate solution. And so I work out my ionic product. Now I compare it to the equilibrium solubility product, and you'll see that's 10 to the minus 9. This is 10 to the minus 5, so this is a lot bigger. It means I've got a lot more ions in solution than there would be at equilibrium, so I'm going to get a precipitation of calcium carbonate until those ions reach the correct concentration. So yes, a precipitate will form. So hopefully you can now do some of the calculations for predicting a precipitate. Kia ora.